Okay, so good morning. The problem sets are maybe making their way around. Does somebody have the? Yes. Okay. So just sort of find yours and pass it around. This is PS1, the first problem set. We're still working on the second problem set, and I don't know. There's a few enough people here right now that. So historically, I prefer to give out like hard copies of the solutions rather than PDFs, just because we don't reuse exam questions, but we do reuse the problem set questions. I don't think, even with a few people are here right now, I don't think that there's enough to go around before our copier broke, which happens with exceeding frequency, unfortunately. So I can start passing out, but I think I'm just going to post the PDFs because, frankly, at the end of the day, if you had access to PDF or you even had access to a hard copy from previous year and you use that to do the problem sets, you're going to just get totally creamed on the exam. So problem sets aren't enough of a grade to sort of really make any sense to try to cheat on them. That's just a public service announcement in case or for future years than the current year. But, okay, so I think I'll just do the post PDFs after class or this afternoon for PS1 and for PS2 as well. So today I want to talk about air pollution and health, which is sort of the first segment of environmental factors that affect health that we'll be talking about. And there's kind of two separate sections. There's a bunch of papers on the syllabus that we're going to review right now, and they can kind of be broken into two categories. One is looking at the effects of air pollution on children's health, really like infant, neonatal, and infant health, and then the next is looking at the effect of air pollution on adult health. The reason that there's this sort of this categorization here is not just that there could be different effects on infants than on adults, so that's certainly true. It also turns out that basically it's much easier to find studies with what we call good research designs. Like research designs are likely to estimate causal effects when you're looking at infants than it is when you're looking at adults. So that's something I'll talk about as we sort of go through it. But basically the timing works out such that you can plausibly estimate the causal effects of air pollution on infant health, but it's much harder to estimate the causal effects of air pollution on adult health. So air pollution is what I would say really sort of the textbook example of an externality, and it's one that we sort of talked about before, like oil refineries, enrichment, and so forth. I think typically when you just say pollution, people would assume that you're referring to air pollution rather than other forms. It's probably because airborne pollutants have the greatest potential for dispersal, so it's really easy for them to go for tens, hundreds, even thousands of miles. So it actually turns out that I don't know if you've read any articles about this, but it was in the news that a non-trivial amount of the particulate pollution in Northern California now, on the West Coast, is actually coming all the way from China. So I think when I first saw that, when I first saw an article about that, I was a little bit skeptical just because it seemed like a long way to travel, and it also seemed like the type of thing that regardless of sort of whether the science was well established or not, it's the type of thing that the media would certainly like to print because it's going to get a lot of page views, basically, right? But I've actually sort of talked to some people involved in research, and they are able to. So there's two reasons why I come around towards believing it. One is that essentially, you can look at when you actually look at the particulates that you take a sample of the air here and look at the actual species of the particulates, you can to some degree sort of categorize where they would have likely come from, and so. Through the categorization, they are able to see that some of them, or a non-trivial fraction of them, seem to have been generated from Asia. The other is that it's actually possible to sort of relate events in China that we know would be affecting air pollution to spikes several weeks later on the West Coast. So basically, the timing. So the timing, given that we know approximately how fast the jet stream moves and so forth, we can have a reasonable estimate of when we should, what the lags would be between having given in China and seeing the results out here, and that kind of timing matches up as well. So, so airborne pollutants basically could go halfway across the world. It seems like these days. In comparison, if you think about sort of land pollution, which would be looking at just garbage and toxic waste and stuff, that doesn't really have that much potential for dispersal. So because of that, if the pollution isn't really dispersing all that much, then the individual who does the polluting potentially could bear a greater share of the actual pollution cost, which would then limit the externality. Because if you're actually just imposing the cost on yourself, it's no longer an externality. So if you just throw trash in your backyard, then at least to the extent that your neighbors can't see it, we don't really care. That's what you want to do, right? And then water pollution certainly has much greater potential for dispersal, but still is potentially limited. Individuals maybe living adjacent to water, unless the drinking water becomes contaminated. So I'll actually talk a little bit later on about fracking, the injection of hydraulic fluids into the ground to try to increase output in oil wells, which people are concerned could be putting drinking water in various states. So we'll talk about some of the evidence on that a little bit later. But with airborne pollutants, it's pretty clear that everybody who is in a given area, that's within the dispersal area of the pollutant is going to potentially be affected. So because of this, air pollution, because these facts make air pollution is basically a case where you're almost certain that the Coase theorem is going to fail. There's guaranteed to be a large number of negotiating parties, right? So if you have hundreds or thousands, or in this case even millions of people who are potentially being affected by the externality, there's no way that they're all going to be able to sort of coordinate and try to bargain with whoever is generating the externality. So it's very unlikely that some sort of private negotiations are possibly going to yield an optimal solution. So in order to try to address the externality, it's pretty much given that you would need to have some sort of government intervention. But before you can think about what would we like, so there's sort of two questions: what would we like government to do, and then how could we, once we decide what we would like them to do, how can we actually design a system in which they do that? The second question is probably more of a political science question, but the first question is something that, as economists, we would like to be able to answer. So basically, how large is the externality and how dangerous is air pollution? Those are empirical questions, and they're very important for determining what the optimal policy would be in response. So if you're thinking about doing some sort of tax or potentially a cap and trade type of approach to air pollution, which we do have, not so much in California. So you might have heard of cap and trade in California. That's referring to carbon emissions, which is, so carbon technically is an air pollutant from a global standpoint, but it's not. When we're sort of looking at health effects of air pollutants, that's not something we're looking at because nobody gets sick from breathing in carbon dioxide. The only way you're going to get sick is eventually if the planet warms up, and then either there's a heat wave or increased communicable disease or something like that. But we're talking here about the direct effect of air pollution on your health. So California does have cap and trade with respect to carbon, but we don't have it with respect to the sort of typical air pollutants that you would think would affect health, like ozone or carbon monoxide or something like that. There's actually a cap and trade system for sulfur dioxide, which is more on the East Coast and the Midwest, I think. So that's a pollutant that is implicated in acid rain, which I think is not so much. It's not something people talk so much about, in part because the sulfur dioxide regulations were successful at reducing it. But it does. it does basically acidify the rain, which then falls in lakes and acidifies those, has negative effects. Some time ago, they set up a cap and trade system, basically involving like utilities and so forth on the East Coast and the Midwest to regulate the total amount of sulfur dioxide. And the argument in favor of doing sort of a cap and trade system, as opposed to just directly regulating utilities and telling them they have to reduce SO2 emissions by some amount, is that potentially some utilities might be able to reduce them at like relatively low cost, and some can reduce them at higher cost. And so you'd like the ones that can do reduce emissions at a cheaper cost to basically bear more of the emissions reduction. But then of course you want to compensate them for that. So you sort of like issue a certain number of credits out there, and then people can trade credits. And if you're a sort of high cost emitter in terms of like it would cost you a lot to reduce your emissions, then it's more profitable for you to buy the extra credits from the low cost emitter and for them to basically reduce their emissions even further than they would otherwise have needed to do so, and just take the cash that you're willing to give them. You mean where are the points of failure? Yeah, so I think there's sort of multiple points of failure. So first of all, you need to actually define the property rights and assign them to somebody. You're right that they're not defined, and even if we did, it's not clear where we would assign them. The other issue though, so the large number of parties is like even if you were to say, okay, we're going to, so say like we're like, okay, we're going to define the property right to clean air in the San Francisco Bay Area metropolitan area, right? And then we're going to assign it to basically the entire population that lives in that area. And so if you want to emit into that area, then you have to negotiate with that population to basically pay some cost. And that's true even if you are part of the population, like you have to negotiate or like get some sort of permit or something that will allow you to emit a certain amount. In that scenario, even after you define the property right, there's like 7 million people in the area. So like where do you even start? And how do you sort of like divide up the property right among the 7 million? So it's not. So you mean like spectrum, basically? When you say radio wavelengths, you're talking about when the government auctions off like various like parts of the spectrum to like AT&T and Verizon and so forth, right? So I mean, I guess what you're that's like that. I guess that's a public good, and I guess that you could view it as essentially pollution. That you have like so that the pollutant now is like emitting a signal that would interfere with other signals in that range, and so what you're doing is basically saying like you have the right, whatever party ends up winning the auction for a given band has the right to sort of clean usage of that band. So like they can quote unquote pollute it with their own signal, but nobody else can do so. It's not it's not like technically I don't know. I mean I guess it still involved like government intervention. So the government of course has to define the property right and essentially says that they're basically taking ownership of it, and then the way that it works then they're like auctioning it off to various companies. And I guess the companies could certainly sell the rights to each other. You see that sometimes, especially like when mergers come up, when like AT&T wants to buy T-Mobile or whatever. So you could think of that as basically sort of a pollution problem and kind of like an application of the Coase theorem. And it's also true that even like all of the devices that we're using right now in the classroom are regulated by the FCC to not emit like radio waves beyond a certain radius or whatever, interfere with frequencies. So they are. I mean, it really is sort of like a pollution problem in that sense. Okay, so anyway, so to get an idea of like where we want to set a cap if we're going to do cap and trade, so like how much we want to regulate the pollution, or what kind of tax we would want to charge if we were thinking about doing an emissions tax, or even if we're just doing what we call like command and control regulation, where we just come in and say here's standards that you have to implement, like here's equipment you have to install in plants or catalytic converters in cars and so forth, to sort of come up with the optimal tax or the optimal cap, or even just what types of equipment you want to mandate. You need to know how big the externality is in terms of like economic cost. So that's going to eventually be mapped into dollars, but before we can even get into thinking about dollars, you have to think about like what are the actual health impacts in terms of illness and mortality. So this is an empirical question, and just to sort of give some motivation, so this is an aerial picture of Los Angeles in 2004, and you can sort of see the smog. You can see that like all the pollution seems to kind of like hang right over the city, which seems undesirable. And what happens here? So we don't do like very much like atmospheric science or anything in this class, but the one thing I have learned about inversion layers is that essentially what happens is, ironically, even though you think about the generation of pollution, it's mostly during the daytime because that's when most of the cars are driving and that's when the factories would be operating and so forth. The buildup of pollution actually gets worse at night, at least in many areas, including Los Angeles. And the thing that happens is that essentially, so typically as you go up in altitude, it gets colder and colder, right? So if you like go up 50,000 feet in the air, then you're talking like negative 20 or negative 40 degrees centigrade or something like that. So like if you stepped out of an airplane, it would be very cold immediately, among other things. But this actually reverses at night. So basically what happens is that at night, the ground, I guess, cools off more quickly. And so as you go up, so like for a sort of relatively short distance, as you go up in altitude, it actually starts getting warmer up until some point at which then you're far enough away from the ground that kind of the natural pattern reemerges and it starts getting cooler. And so that point at which it goes from getting warmer as you go up to getting cooler as you go up is what's called the inversion layer. And that ends up basically forming like a cap that traps all of the pollutants. So I haven't done it myself, but I've been told by some of the people in like the atmospheric sciences department that if you went up to Grizzly Peak and watched the sunrise, essentially, so like when the hills over there and watched the sunrise, what you would see is that there would sort of be a lot of visible pollution or even just moisture like trapped below the inversion layer. And the sun rises, starts heating up the ground. The inversion layer disappears and goes back to sort of the natural state where it's just continuously getting cooler as you go up in altitude. And in like a relatively short period of time, suddenly all of this stuff would disappear. So this is sort of a picture of Los Angeles, early in the morning before the ground has heated up enough and the inversion layer is still visible. So Los Angeles no longer is the worst polluted area in the U.S. and certainly it doesn't compare to something like Beijing. But historically, it had relatively bad pollution because of a combination of there's a lot of people living there, there's a lot of cars, and then also it has like unfavorable atmospheric conditions because of the inversion layer. I think now like Houston and other places have overtaken in part because California does have the sort of most aggressive pollution control restrictions in the United States. So there have been a series of studies that have looked at infant health, the effects of air pollution on infant health, and that's what we're going to talk about first. Then we'll talk about adult health later. But the sort of one of the first studies in the economics literature that really tried to address this problem is this paper by Ken Shea and Michael Greenstone, which studied the impact of air pollution on infant health. So I think there's very little doubt that like very radically elevated levels of air pollution are bad for human health. So there was like this episode in London, which was called the Great Smog in 1952, where there was kind of a confluence of events in terms of weather conditions and emissions and so forth that created like absurdly high pollution levels, and you could sort of see a spike in mortality that occurred when those levels were present. But in developed countries, sort of radically elevated levels of air pollution are pretty rare these days, unless there's some sort of crazy event like a giant fire. The correlation between air pollution exposure and infant mortality is likely positive. So if you looked, both over time and over space, you would tend to find a positive relationship between infant mortality and air pollution. Over time, infant mortality has been trending downwards, air pollution has been trending downwards. It's unlikely that those two things that you would want to interpret those, the correlation of those two trends as being like a causal, having a causal interpretation, because a lot of things are occurring with medical technology and so forth that improve survival of infants, and at the same time we're also getting better pollution control technology and so forth. So air pollution is also going down over time. So how much of the correlation represents causal effect and how much is due to unobserved factors? If you're looking over space, you would find probably poor areas have higher pollution and also higher infant mortality, but obviously socioeconomic status differs over those areas, population density, and a whole bunch of factors. So you want to just look at like the raw correlations here and interpret those as causal effects. So what Shea and Greenstone do is they use this recession that happened in the early 1980s as essentially a natural experiment that changed air pollution levels. So they're going to do like a differences in differences type study here, and the sort of core idea is that they can use changes in air pollution levels that are induced specifically by the recession to estimate the effect of air pollution on infant mortality. So the idea is that in back in the early 1980s, manufacturing was a larger part of the U.S. economy than it is now, and in particular in like sort of Midwest, it was a larger part. So if you just look in the data, you can actually see that there's a substantial reduction in particulate pollution as polluting industries shut down during the recession. So typically we think recessions are bad things, and they are, but this is sort of saying, look, there's some upside, which is that you have these polluting factories that were operating, then there's a recession, a lot of them go out of business, and pollution actually falls. So there's an overall reduction in total suspended particulates, but critically for the research design they use, the actual reduction at the county level varies widely across counties. So there are some counties that had a high density of polluting industries before the recession hit. So in those counties, you saw pretty large reductions in TSPs. And then there are other counties that had relatively low density of polluting industries. So if your county was already based more in terms of like the service sector than manufacturing sector, if most of your employment was outside of manufacturing, then there aren't really any factories to shut down anyway. And so the recession certainly could have impacts on your county. People still might get unemployed, but you're not likely to see a substantial change in air pollution due to the recession. So what they're going to do is essentially leverage that difference and sort of look at like the pre-treatment or the pre-recession density of sort of polluting industries in your county, and use that as essentially like sort of an indicator for your county being treated, your county's pollution level being treated during the recession, and then look at control counties that don't have a whole lot of polluting industries, and use those as kind of like a control group that is potentially affected by the other factors that are changing due to the recession, but that don't see a substantial decline in total suspended particulates because there's sort of not a lot of industry shut down there to begin with. So the way that they're actually going to, they don't go through and sort of like try to identify the number of factories in each of the counties, although that would sort of be an interesting exercise to see whether or not the variation is actually being generated by the story that they're telling here. What they actually do is just look at the pollution measurement levels and say, okay, the treated counties are going to be ones that we observe large TSP reductions and large reductions in total suspended particulates, and then the control counties are going to be counties that we see sort of smaller or no TSP reductions. And the outcome that they're interested in is infant mortality. So they're going to see how infant mortality changes in these counties that are seeing a sharp drop in TSPs compared to the change in infant mortality for counties that aren't seeing any substantial drop. So when they sort of implement this research design and get the data, what they find is that a 1% decrease in total suspended particulates is associated with about a 0.35% decrease in infant mortality rate. So if you want to think of it in terms of elasticities, it would be like elasticity of about a third there. In terms of interpreting whether or not we think this is an actual causal effect as opposed to some artifact that's caused by like bias in their research design, the most important thing, since it is a diffs and diffs type study, the most important thing to think about is whether or not there could be factors that are changing in these high TSP reduction counties relative to the low TSP reduction counties that might be able to explain the results. So again, this is not something that you can definitively test because there's always going to be some sort of like factor that could have an impact on the outcome, but that you don't have data on because no data set has like data on every single variable in the world. So you'll always be able to tell some story that there's some like limited variable behind the scenes that's changing differentially for the treated county relative to the control county. But they do have some observable characteristics for the counties. Some things that they think should help explain or should have explanatory power for infant mortality, and they can look at whether or not these observable factors are changing differentially in the treated counties versus the control counties. And if they are, then that would be evidence that the research design is probably broken because if the observable factors that determine infant mortality are changing differentially in the two counties, then the unobservable factors are probably also changing differentially. If not, then that's suggestive that the research design is in fact valid. By the same argument that the observable factors are looking like they're trending similarly in the two counties, and hopefully the unobservable